Hello students, welcome back to the next module of our chapter called electromagnetic induction. Right now students, in the previous module we have already covered two parts of the concept called as self-induction, and in this particular module we'll continue with the third part of this particular concept called as self-induction. Right, so let us start. Now students, we have already defined this particular term called self-induction. Right, do you remember? Yes, it is a phenomena of production of induced EMF in a coil due to the change in the value of current in the same coil is called as self-induction. Right, so what is the definition? The phenomena of production of induced EMF in the coil due to the change in current in the same coil is called as self-induction. Right, now students, to understand this particular concept of self-induction, we have taken a coil, and in that particular coil current was changing, and because of the change in current there was a change in flux, and because of the change in flux there was induced EMF which was produced in the coil. Right, and we have also found out the formula for induced EMF. So the formula for induced EMF in case of self-induction is given by E, it is equal to minus L into di by dt, where E is the induced EMF due to self-induction, L is the coefficient of self-inductance, and di by dt represents the rate at which current is changing. Right, and students, in this particular case, what is the reason behind induced EMF? The reason behind induced EMF is change in current with respect to time. Right, and that's why this induced EMF will oppose the change in current in the circuit, and that's why you can see negative sign over here. And what does this negative sign indicates? It indicates that EMF is opposing the rate of change of current. Right, now see carefully, it is opposing the change in the value of current. Right, and that's why I can say self-inductance of the circuit is that property of the circuit which opposes any change in the value of current in the circuit. Right, now this property is exactly similar to that word that we have learned in mechanics, and that property or that word is referred as inertia. Right, do you remember what is inertia? Inertia is that particular property which opposes the change in state of rest or change in the state of uniform motion of a given body. Right, in the similar terms, self-inductance is that particular property which opposes the change in the value of current. Right, and thus I can say self-inductance is also referred as electrical inertia, or it is also referred as the measure of electrical inertia. Now let us move further. Let us start with the uses, or rather the various application where this concept of self-induction is used. It is widely used in a device called as choke coil. Now students, this particular device called as choke coil, it is basically used in fluorescent lamps or in fluorescent tubes. Right, now see the diagram carefully. This diagram is of choke coil. Now what can you see in this particular diagram? There are large number of turns of insulated copper wire which is wound on a cylindrical ring which is insulator. Right, or I can say it is nothing but coil of large number of turns of insulated copper wire which is wound on insulating cylinder. Right, now students, this particular device called as choke coil, it basically acts as opposition to AC circuit. Right, the way resistor acts in DC circuit. Right, now students, this particular device called as choke coil, it is basically used to control the value of current. Right, so that we can maintain the discharge uniform. Now let us move further. Now students, instead of choke coil, if we connect resistor to a fluorescent tube, then what will happen? Then in that case there will be loss of power due to joules heating, or rather there will be wastage of power due to joules heating. Right, and this power will be very huge. This loss of power will be very huge. Now let's say if I connect a choke coil, or rather in fluorescent tube, if choke coil is connected, right, so as to decrease the value of current of AC means, then the wastage of electrical power will also be very less. Right, and lastly, if we connect this fluorescent tube directly to a AC source, right, so let's say fluorescent tube is directly connected to AC means, then in that case this tube will draw large amount of power, or it will draw large amount of current, and it may get damaged also. Right, now let us move further. Let us solve one numerical which is based on the concept of self-inductance. Now read the question carefully. It says the back EMF in the inductance coil is 200 volts. When the current in the coil changes from 0 to 2 ampere in 0.01 second. Calculate the self-inductance of the coil. Now students, in this case, we are provided with back EMF. We are also provided with the variation in current in a given time span, and we are supposed to calculate the value of self-inductance. Right? Now let us analyze this and let us write down the given data. First of all, we are provided with a back EMF, so I can write E, it is equal to 200 volts. When the current in the coil is changing from 0 to 2 ampere in 0.01 second. So from this, I can calculate the change in value of current with respect to time, or I can calculate di by dt, and it is given by 0 minus 2 upon 0.01, because current is changing from 0 to 2 ampere in how much time? In 0.01 seconds. And if you calculate this will come out as 200 ampere per second. Right? What we are supposed to calculate? Here we are supposed to calculate self-inductance, that is capital L. And the formula that we'll be using is E, it is equal to mod of L di by dt. Right? Now let us move further. Let us start with the solution. Now we know the formula. E, it is equal to mod of L di by dt, and therefore L, it is equal to mod of E upon di by dt. Right? Now see the given data. Right? We know value of E. What is the value of E? It is 200 volts. So let us substitute. And di by dt is also equal to 200 ampere per second. So here we will get 200 upon 200, and finally we will get L, it is equal to 1 Henry. So in this case, the coefficient of self-inductance, it is equal to 1. So students, in this particular module, finally we have finished the concept called as self-inductance. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.
बहुत बहुत बस आवाज़ पूरा